Hey everyone, so now that we know how to simplify radicals, we're going to take a look at multiplying radicals. Okay, so when multiplying radicals, we still need to be able to recognize our perfect squares, so that's why I still have this slide in here. It's really, really important that you know these, either have them written down, have this printed out, but you definitely need your list of perfect squares because we're still going to have to simplify our radicals. So we're going to have to take the skills from the last two lessons and we're going to have to apply that to our products, and you'll see when we do an example. So it's really important that you have these perfect squares with you at all times, either written down or printed out or memorized, which is number one. Okay, so when we multiply radicals, we multiply the radicands. Hopefully you remember that vocab word. That's the number that's inside the radical. So we're going to multiply the numbers inside the radical, and then we're going to simplify like what we did before. So it's very straightforward. Multiply, then simplify. So let's take a look at an example. So expressed in simplest radical form, we have radical 5 and then we have radical 10. Now notice they're right next to each other. There's nothing in between them. So that means multiplication. There's a little invisible multiplication symbol in there. It's not always necessarily going to show up like this. You could also see a little dot in between. You can see parentheses. It can ask for the product and they won't even be next to each other. And hopefully you remember that product means multiplication. But in this case, we don't have anything in between them, no plus sign, no minus sign. So that automatically means multiplication. So just like we set up here, we're going to multiply our radicands. So our radicands are 5 and 10. 5 times 10 gives us 50. So we're going to take that product and we're going to put it right under, so I'm going to just multiply these out, and we're going to put it right under a new radical symbol. So 5 times 10 is 50, so we get radical 50. Just like when we were simplifying and we were able to break them apart, when we're multiplying, we're able to bring them back together. So now we're going to simplify, and we want to find the largest perfect square that goes into 50. So you should have your perfect square list ready. Oh, that's not 28. That's my mistake. It's 25. So it's okay to make mistakes as long as you catch them. Blah, blah, blah. Keeps going. And the largest perfect square on this list that can go into 50 is 25. So I'm going to break this into radical 25. And then 25 times 2 would give us 50. So it's weird. We're kind of bringing it together and then we're breaking it apart again. Because we need that perfect square, always remember to write your perfect square first. So we don't want to put radical 2, radical 25. We want to put the perfect square first, so then the coefficient automatically goes on the outside of the radical. So we don't have any confusion there. Now let's simplify this radical 25. The square root of 25 is 5, because 5 times 5 is 25. And we cannot simplify radical 2, so we're going to just bring that down. And that is our answer, 5 radical 2. So multiply your radicands and then simplify. Let's take a look at another example. Expressed in simplest radical form. So even if you want to put that little dot right there, you can. But we see that there's nothing in between, so we can automatically assume multiplication. So we're going to multiply our radicands. 8 times 56. So this one's going to give us a number that's a little bit bigger. So I just want to circle my radicands so we know that we're multiplying those. And I'm going to put that underneath a new radical symbol. And 8 times 56 gives us 448. Okay, so this number is a little bit big, so you might have to do some guess and check, some trial and error when trying to find that largest perfect square. Or you can start by dividing a number that you know can go into it, like if you want to start with 4, because that's a perfect square, and then just keep simplifying from there. That's totally fine too, as long as you keep simplifying until you don't have anything to simplify anymore. But I'm going to just go with the largest perfect square. I did a lot of trial and error. I did a lot of division. 448 divided by, 36 divided by 144. I tried all these different combinations, and I saw that 444 can be divided by 64, which is a perfect square. So I'm going to break this out. So we get the square root of 64. And 64 times 7 gives us 448. So if you want to write that little division on the side so you know where those two numbers are coming from, that's totally fine. There we go. So 64 is the largest perfect square that can go into 448. So we're going to simplify the square root of 64, which is 8, because 8 times 8 is 64. Bring down your radical 7, and you're done. So we multiplied our radicands, got 448, found the largest perfect square that went into 448, which was 64, and then just simplified from there. All right, let's take a look at one more example. Now this one kind of looks simple, and it is. I just wanted to show you an example because sometimes this happens. So we're going to do the same thing. We want to express this in simplest radical form. We know we're multiplying. So I'm going to be multiplying these radicands. And 6 times 6 gives us 36. Now, when we simplify the square root of 36, hopefully you'll recognize that gives us just the number 6. So it's okay to sometimes get a whole number here. If you have the same number under both radicands, under both radical symbols, you are going to get a whole number in the end. It's mainly because, and I'm going to show you on the side, this is the same. So if you write radical 6 times radical 6, this is something times itself. So that gives us the square root of 6. Let me just write that a little bit clearer. For some reason, it's not working too well. Okay. That gives us the square root of 6 squared, because it's something times itself. Remember, whenever anything is times itself, we can kind of condense that and write it in exponent form instead of expanded form. Finding the square root of something and squaring something are inverses. They're opposites. They cancel each other out, just like multiplication and division, addition and subtraction, they're opposites. So they cancel each other out. So in this case, this square root symbol can cancel out with that squared, and then you're just left with the number 6. And that's totally fine. So if you have the same radicand, you're going to end up with a whole number because those square roots are just going to cancel each other out pretty much.